Right, welcome back again to this course. So we are going to look at tests. Basically, we're going to look at t-test, ANOVA, and ANOSIM. Actually, ANOVA is not needed actually under this particular test because we only have two groups, which is under our. We have two groups. If you look at it very well, this is in the categorical variable. We have two groups, Fragile X and Williams. So those are the two groups we have. So, but I'm going to also perform ANOVA for it, just to, in case some of us may later have more than two groups later that we want to compete on. So we need to know how to do that. So I'm going to compute ANOVA as well, so that I'm also going to explain that further in the analysis, so that you can understand how to do that. Then I will compute a t-test on it. I will also compute ANOSIM. So let's go. So this is what we have left last time. If you remember, this one can be here, it can be here. So I brought it here so that you can look at it properly. So here we can copy this now. Here, this one can copy it to our past now. Just copy, right? I copy this. We don't need all of this actually. We don't need one alongside with this guy. So, but we want to know which one can we use among them. We don't need all of them. So let's go to our past now. This is our past. Okay, past. So we click on this column attributes. Okay, we don't need row attributes because we don't have any row observations identity. All right, so that's why we won't select that. We only select column attributes. So click here on here. All right, we paste here. All right, so we select here, open, say call it group. So this was a group variable. So we lose this out. All right, so that is how you set your variable here. So now that you have come here, so we need to understand that you need to test your variable first against what is called parametric assumptions. Now, because we want to perform parametric tests actually, because t-test and ANOVA, they are all parametric tests, and they both come along with assumptions, especially assumption for normality assumptions, objective variance assumptions, outliers assumptions, and the rest of them. So at least you must meet at least two of them for you to continue with this particular t-test ANOVA. So we need to check which one of those variables that we have here that meet the assumptions. Because all of them may not meet the assumptions. So for example, if you check now, for example, now we want to understand that if you run Shapiro first, Shapiro test to check for our normality test, Shapiro test, if it is significant, it means that we did not meet the assumption. So, but if it's not significant, it means we meet the assumption. So that is how it works. The same thing with a Levin test. All right, the test for objective variance. So you must understand how it works. So it must not be significant. That's what it means. If it does, then it means that we did not meet the assumption. So that is what it means because of the setting of hypothesis. It's always set to negative. So now we want to test this one first. Let's see this line first and see if this one if it meets the assumption for this. So we go to univariate here. All right, so here we go to normality test. Normality test here. Click here. So we want to test first. All right, so we want to see Shapiro test 0.0, 0.02. This one is significant. So this one does not meet the assumption automatically. So you can see. Let's first check this summary first. Summary first. You can see the kurtosis, and the skewness. Skewness must be as close to 0 as possible. You can see this one they are not both close to 0. They are very far from 0. You can see that. So which means that it does not meet the assumption. All right. So let's look at another one here. We are not going to use all of them. We're going to use only one. But one must meet from this variable must meet the assumptions. So let's see this first. The summary of this first. I think this one is closer to 0. This one is 0.02. That is close to 0. This one is 0.09. I think this one is close to 0. then one is close to assumption. So let's go and check. Let's go and do the test. The test now, normality test. So Shapiro 0.9. So this is not significant. This is okay. This meet the assumption. It meets our assumption for the normality check. It passed the test. So P2 can be used to compute the normality check for this analysis. So the rest can be, you can see further check more the rest. So there's no time for that, okay? So that you will not be checking everything one by one. So you can do that later by yourself. So, but you can see that this P is 0.9. It's greater than 0.05. So it means it's passed the test for assumption. So it's not significant. And they consider Anderson also and Monte Carlo. So what we are our focus in is Shapiro. All right, so that is that for that, and you can further test other tests to confirm this hypothesis. So you can now run our test on this line. Let's run the test first. We select this line, this line, and this line. You down your shift key, your control key rather, control key, while you select this and this together, so that you can select the two together. We need this categorical variable and this variable here, computer 2, can be component 2 to compute our analysis. So you can go to Variability here. Now you want to do a t-test first. All right, so you go to sample test here, and we click here, click on sample test. So the first one is a t-test. That's what we are going to do. So we are looking at Fragile X and Williams, and t-test is to compare the mean of the two groups, to compare the mean. So this test is just to compare the mean of two groups if they are the same. And this particular test is telling us that this mean that they have difference between the mean is 0.023. They are not the same. So there's a difference in mean. That's what it means. And with a p-value of 0.0268, which is significant, less than 0.05. All right. So we can do that here that the mean of this particular, the t-test here, the mean here is not the same. All right, it's different. They have different mean. All right, so that is clear under this assumption. So that one is clarified. That is just simple way to analyze your t-test, and very fast. All right, so that is clear. Then the same thing you can also use to test. Also, you can also test your ANOVA here. ANOVA. Let me from here go to ANOVA here. Click on the first one here. All right. So the first one is this one with ANOVA. All right. So we are testing the ANOVA here. ANOVA is also giving us 0.0824, not too far from the former what we got before, 0.0284 now. So ANOVA is significant as well. All right. So we should show that and if you look at it very well, this 11 test also was met, because 11 test is not significant here, which is homogeneous appearance, which means that it meets the assumption for homogeneous appearance already. All right, that must not be significant. All right, which is correct for our parametric test. Okay, so if you check the residual here, you understand that the residual here is talking about this KQ plot. Okay. This KQ plot. Okay, that's how we look at it. So we want to also look at it in this form, in histogram form. You can see that it seems to be well distributed. Okay, so this is our. So we may need to check it that way. So let me just go back to now. So this is our text here. So we can see that it's significant here, and our F is. I'm going to interpret this more on this ANOVA towards the end of the chapter. Toward the end of the chapter, I'm going to interpret on this, speak on this more, on these parameters that we have in here one by one. So don't worry there. So that's not a problem for now. I think you are not meeting assumption for the parametric test now. We can go to Whitney. Kurzkawali for ANOVA. That is but we are meeting assumption, so we don't need to do Kurzkawali. So assumption is met already for ANOVA test. Another test that is very significant, also that I want us to look at critically, is called ANOSIM. ANOSIM test is a very powerful test, and when you look at under multivariate, go to test, go to one with ANOSIM. Yeah, one with ANOSIM is a very powerful test. You can see what is showing out here. showing us that this is P is not significant, 0.08. Why? It must not be significant because ANOSIM means analysis of similarity. Analysis of similarity, that's what it means. Analysis of similarity. So it means that the two shapes we are comparing now, the two faces of this ANOSIM is usually used for morphometric shape analysis. We are comparing a configuration of two sets of shapes together, maybe face of this and face of this, or two species. You want to check, you want to know, you want to decipher if they are similar. You can use this to check and the result. So this is test for analysis of similarity if they are similar. So, but when we check now, we see that the test is not significant, which means they are dissimilar. They are not similar. That's what it means. So if they are significant now, if the test is significant, it means they are similar. All right. But now we confirm that they are not similar in face shape, which means their face shape is different. The face shape of the fragile S and face shape of the Williams Buren, they are not the same. So that is what the test confirmed for us, and that also confirms our result we got through our machine learning, that we were able to see some discrepancy or some distinction in the analysis, that they are not the same. So we were able to discriminate for us and predict for us a high accuracy. All right, so that is test for now. So, but for the ANOVA, I will explain further about ANOVA towards the end of this group. But this one is just straightforward, and you can bus plot. You see the bus plot here. If you want to check if there's any outliers, which there is none. All right, so that is that for now. So we see us in the next section. So you can copy out those things, copy them out. You can just click on copy and put them in Excel, or also we can copy the first one that we did before, which is ANOVA. We're going to use that later, ANOVA later. This one, when we ANOVA, I'm going to copy this one and put it in Excel sheet. We're going to use it later for analysis later towards the end of the chapter, because I believe many of us will be using more than two groups. Okay, mine is just two groups for now, and I believe many will be using more than two groups later. So that is that for now, and I will see you in the next class. Thank you so much. Don't forget to check your assumptions first before we go further. If not, you have to move on to non-parametric test. Okay. Thank you so much. I will see you in the next class.